Welcome back to Cradle to Grave Algebra. Today we're going to talk a little bit more about sets, then I promise we'll slow down and start something else. So let's knock this thing out. We're going to talk about different types of numbering, that being the natural numbers, whole numbers, integers, quotients, and the real number line. We've talked about the real number line before, so I think I'll start with that. The real number is every single number you can possibly think of and imagine that is not imaginary. So numbers that are actually real, which include decimals, fractions, irrational numbers. We'll get more into that in a second. Let's go ahead and define what the natural numbers are. The natural numbers, or the counted numbers, are the letter N, it's called. That's how we denote it, natural. So the natural numbers don't include zero or negative numbers, and they only include full whole numbers. So it's the counted numbers, 1, 2, 3, 4, 5, dot, dot, dot. And notice how I denote that. Let me see if I can go ahead and point with this thing. So the N is equal to 1, 2, 3, 4, dot, dot, dot. It means it goes on forever, but you get the pattern. There's no 1.2 or 1.5 or 2.7. There's no pi's in there. It's just the counted numbers. So we can kind of plot those onto a real or a number system. So you have the 0 here, you have the 1, 2, 3, dot, dot, dot. Understandably, it goes on forever. So let's just go ahead and pick the 1, 2, 3, and 4 and plot those. So the number 1, it's a solid, don't forget, because it does include the exact number 1, the exact number 2, the exact number 3, and so forth. Now you can denote this goes on forever with a fat arrow if you'd like, but you can't possibly put the dot on each and every one of these, so it's not very practical to actually do that. But that's what it looks like if you were to visualize it. It'd be a dot on every single number, but not including 0, so that's key. It doesn't include 0, and it doesn't include negative numbers. So that was the natural numbers. Now let's go ahead and look at the whole numbers, which is right here. So the whole numbers is everything that's natural and the number 0. So it's literally, so let's just mark this as an N here. This is the whole numbers. So 0 is included, 1, 2, 3, dot, dot, dot. It goes on forever and ever and ever. So the only difference is that number 0. You could say that N is a subset of W, but W is not a subset of N. Because every single number in N is in W, but not every number in W is in N, namely that 0. Okay, let's move on. So Q. Q is a special one here. Q is any number that you can represent with a fraction. So 2 over 3, 1 over 4, all the decimal numbers. It could be 5 over 2. It doesn't have to be, the numerator doesn't have to be bigger than the denominator or less than. It's any fraction. If you can make it into a fraction, then it's on this Q number line, right? Now, not every single number can be made into a fraction. You can even make numbers like 0.33333 that goes on for infinity. Put that little line across there. Oh, I'm in the way. Let me jump out of the way here. So you can even make numbers like 0.333 repeated forever, dot, dot, dot. Goes on forever. You can make those with fractions. What is 1/3? Well, 1/3 does equal this. 1/3 does equal 0.33. Try it in your calculator. It goes on forever, dot, dot, dot. You can't possibly represent that with decimals, but 1/3 is on the Q number line. Now, we can't possibly put an infinite amount of numbers on this number line, so we're not going to graph it at all. But what I really wanted to show you is the importance of the fact that Q and R are two different things. Now, R is the real number line, right? Remember the double, usually it has the, let me make that a little neater. It has the double line here. So the set of all real numbers is every number you can possibly think of. So what numbers are in R but not in Q? Let's think about that. Well, the number pi is equal to 3.14159 dot, dot, dot. It does not repeat, and there's no pattern, and you cannot possibly make pi with any fraction whatsoever. So the real number line contains every single number, including all of the fractional numbers, namely this Q, but Q does not contain every real number. Is Q a subset of R? And the answer is yes, because R is all real numbers. Every single number you can possibly imagine that's real. Now, R is not a subset of Q. Like Q contains an infinite number of numbers, just like everything else. The whole numbers do, the natural numbers do, but the Q does not contain numbers like pi or square root of 2, namely the irrational numbers. So square root of 2 is some sort of irrational number that goes on forever, and it does not repeat itself, and there's no pattern to be had. So square root of 2 is not inside of Q, but it is in the real. So this is not a true statement. And that's it. I just wanted to wrap things up with our sets with this lesson. Comment below, ask me some questions, and please share and like this video.